There's been a long-running debate around what kinds of global temperature measurements are most accurate: satellite sensors or surface thermometers on the land and ocean.
The satellite data are the best data we have.
I asked leading scientists, including Dr. Carl Mears, one of the world's preeminent satellite temperature experts, to help clarify.
So what's most accurate?
Well, I would have to say that the surface data seems that it's more accurate.
The most reliable instruments we have are the instruments on the surface of the Earth, and they're the only ones that give us a long-term temperature record that goes back before 1979 or so.
Well, obviously there's a surface thermometer network. I think that actually is very robust. There have been many groups working at completely independent work groups, and they all come up with essentially exactly the same answer.
A number of groups analyze the surface data, including some who set out to prove the other one's wrong, and they all get more or less the same answer.
And we've done a lot of work with the surface record to ensure that reliability. We've tried using just the raw data globally. You get pretty much the same warming. We've tried using various adjustments to correct for instrument moves, time of observation changes, ship buoy transitions, things like that.
And there haven't been the kind of revisions to the surface record that there have been to the satellite record.
There's sort of this misnomer that satellites are this simple, reliable instrument that we can trust with no adjustments and no corrections versus all these messy adjustments that are needed for the surface temperature data. The truth is the exact opposite.
I mean, obviously there are revisions. There are always revisions to every data set as new data come along and people understand it.
We've tried cutting it into different slices, using only urban stations, using only rural stations, and pretty much no matter how you slice up the global surface temperature record, you pretty much get the same result. The adjustments to the surface temperature data that get so much press have very little impact on temperatures in the last 30 years or so. It's almost entirely on the distant past.
But you look at the kinds of errors they've discovered in the satellite record, they're not nearly the same kinds of errors in the surface record.
Spencer and Christie put out the first sort of global satellite record in the 90s, and when they first put it out, it showed cooling since 1979. Whereas all the other records showed warming. At this point, there have been about 7 major adjustments to that record. It went from showing cooling to showing slightly less cooling to showing flat temperatures to showing warming, all over the same period due to subsequent adjustments. Satellite records historically have been subject to much, much larger adjustments over time than the surface record.
You get a much bigger spread of results from the satellite data than you do from the surface data.
And I'd suspect that we're going to see some additional corrections to satellite records in the future.
Both kinds of data sets, you have to do all these adjustments in order to make a long-term data set.
The aim of adjusting the temperatures is because what we're not interested in is the numbers that are produced by instruments. We're interested in the temperature of the planet. And the instrument sometimes gets in the way of actually getting to the temperature because instruments change over time.
The biggest adjustments that are done are actually to ocean data. In 1849, I believe, there was an international agreement to start standardizing the measurements of temperatures on ships. I figured it would be a useful thing to track. Back then, most of the sea surface temperature measurements were done by throwing a bucket overboard, a wooden bucket initially, pulling the bucket up the side of the ship, and measuring the temperature in the bucket. So they started with wooden buckets. They switched to canvas buckets, which were easier to use but had different thermal properties. After the canvas buckets, the next big technology that was used for ships was engine intake valves. So you have a valve on the hull of the ship where water is going through, it's contacting a thermometer, and you can take the measurement.
The clearest change is at the beginning of World War II. Before that, all the data was coming from buckets, and then during the war, there was a big shift to using engine room observations. And the engine room observations, as you might expect, they were a bit warmer because engine rooms are a bit warm. And the bucket observations were cool because of evaporation from the buckets as they were being hauled up on deck of the ship. So when you fix that, you see less warming than if you just deal with the raw data. And most recently, there have been free-floating buoys drifting about the ocean, which measure the temperature all the time and send back radio messages every hour.
So I think the surface record is actually quite a bit more robust than the satellite record. I trust that much more than I trust a satellite record.
The satellite temperature record has problems, and then it has even bigger problems when you switch from one satellite to the next. And of course, that has happened many times over the course of the satellite temperature record.
So I used 13 different satellites. The first one was launched in 1979, and it lasted for a couple years. And then there was another one launched in 1980, and it lasted for maybe 6 years or something like that. So you have this big continuum of satellites. You have to cross-calibrate those satellites.
As the orbits and the instruments are not stable, the instruments gradually decay over time, and the orbits also decay over time.
And that's probably the largest source of error in the satellite data set.
For a claim as important as the Earth is warming, you want to look at lots of data. You want to have lots and lots of data. And so what you can do is you can look at other parts of the climate system that should respond in predictable ways if the climate is warming. So an example is ice. We know ice melts reliably at 32 degrees Fahrenheit. And so on a warming climate, you expect ice to be disappearing. And sure enough, if you look around the climate system, sea ice in the Arctic is disappearing, glaciers are disappearing.
Now basically all the glaciers in the world are retreating.
And so what we're seeing is a gradual progression towards ocean in the north that has no ice on it whatsoever in summer. Right now we're about 60% of the way there.
Sea level is really our best yardstick for measuring human-caused climate change. The fact is that the extra heat trapped in the Earth is almost all going into the oceans. Over 90% of the heat we trap goes into the oceans, expands the water, and causes sea level rise. The glaciers and ice sheets, which are also experiencing the warming atmosphere and the warming ocean, also melt and add extra water to the ocean. That too contributes to sea level rise. So both of those things together give us really a global view of just how much we're pushing the climate into a new realm.
As this video was in its final edit, new findings showed Zeke Hausfather's prediction to be prescient.
We're going to see some additional corrections to satellite records in the future.
Dr. Carl Mears has now published new adjustments to his data set of satellite temperatures, increasing the rate of warming by up to 60%.
So it had the biggest effect on the time after 1998. And previously, if you calculated the trend from 1998 to 2015, for our data set, you got almost no warming at all, or maybe even a little bit of cooling. But now with the new data set, you get about 0.06 degrees centigrade per decade of warming.
Dr. Mears told journalists there are people who like to claim there has been no warming since 1998.
The satellite data show no significant warming whatsoever for the last 18 years. It's just a steady line.
They really can't claim that anymore. In recent weeks, a new study has shown that sea level is rising faster than at any time in at least 2,800 years. Arctic sea ice has set a new record for the lowest February extent ever observed. And the latest measures from surface and satellite sources show that February 2016 was globally the warmest month ever measured by humans in the modern era.